Okay, here's part B of problem 111, page 469. And it says, determine the maximum distance you can throw the ball. So, a lot of times you got to help the author out. What the heck does he mean? Remember that r of theta is v sub o squared all over g times sine of 2 theta. So he wants us to maximize this. So he doesn't mean let's allow v sub o to change, because if you allow v sub o to change, you can throw it to infinity if you can throw it hard enough. Now, what he meant to say was for v sub o equal 34.8 meters per second, find the angle at which this range is maximized. And that might have you scratching your head, but just hold on. Remember that the maximum value of the sine of 2 theta, what's the maximum value? It's 1. And where does that occur? Better draw a quick little picture. Here's 2 theta. Guess what? It occurs at pi over 2. It occurs where 2 theta, this is sine of 2 theta. Where does that occur? Where does the maximum value of 1 occur? At 2 theta equals pi over 2. And when 2 theta equals pi over 2, then theta equals pi over 4, aka 45 degrees. And maybe that makes sense to you. There is an optimum angle, too low, and you're just not putting enough air underneath the ball, too high, and you've thrown it too high, essentially, and you're losing distance in the direction in favor of height. So as it turns out, in this case where there's no air resistance, theta equals 45 degrees is the maximum. Do we have to calculate that maximum? We do. So the maximum then is r of theta max, which occurs when theta equals pi over 4. When theta equals pi over 4, 2 theta is pi over 2, sine is 1. So it's just equal to v squared all over g. And in this case, that would be 34.8 squared all over 9.8 meters. And there's a number in mind here. Should I calculate it real quick? 34.8x squared 9.8 divide. And if I round up, that's 123.6 meters. Again, I would call that one heck of a chuck. Okay, talk to you later.